What would be the hallmarks of a scientific theory of consciousness? What are its desiderata? How would we know if we had one? What's the end goal that everybody is searching for?
I'll answer it by first saying as a physicalist, if I were a physicalist, my desiderata would be. I would say that I had succeeded with a physicalist theory if I could say, for example, in the case of integrated information, this specific Q shape, this specific pattern of integrated information, for theoretical reasons, must be the taste of mint. And here's exactly why it must be the taste of mint and why it could not be anything else. But not just one. I would want to have accounts for thousands and thousands of conscious experiences, right? I want to account, right? If I have a theory of electrodynamics and I say, well, okay, I can account for this electron interaction, and I can account for why I get this kind of light from a photodiode, and I can account for all these very specific things, and I can do it and I can predict the magnetic moment of the electron to 8 decimal places or whatever it is now. So, I mean, if I can do that kind of stuff, then I'm not saying my theory is right, but that would be a sine qua non for me being happy with my theory. This is a theory that's worth overthrowing now. This is not a theory that should be ignored. This is a theory that's worth being overthrown. But if a theory cannot explain even one specific conscious experience, then now that's for any physicalist theory. As soon as they can start to explain specific conscious experiences, not just is something maybe conscious or not, that's way too easy. Specific conscious experiences, then I'm interested. Now for someone like me that's the scientist and saying, okay, I'm not trying to do that. I'm not starting with physical stuff and trying to boot up consciousness. So what do I have to do? So I have to do a couple things before I have a theory that I'm happy with. I have to first have a mathematical theory of consciousness where the math is completely clear. But second, I need to then be able to explain something that I can measure in space-time, right? I need to be able to, so if I'm saying, so I'm going to propose that consciousness is not something that emerges from physical objects inside space-time. That's the standard story, is that the universe began 13.8 billion years ago, although recent data suggests maybe double that now. Maybe it's 27 billion years ago. We'll see. The Big Bang was a long time ago. But the idea is that there were no conscious entities to begin with. There was just the precursors of the particles of the standard model of physics right now, the bosons, leptons, and quarks. But nothing conscious. And then consciousness emerged later on. So I'm starting with a completely different framework than that says the consciousness emerges from physical stuff. I'm saying there's consciousness prior to space-time period. And so for that kind of model, I need to be able to say what the dynamics is, and I need to be able to say what in space-time, like that we think of as particles, like electrons that have mass and position, momentum, and spin. I want to get those properties, specific properties, from my theory of conscious agents. So for me, success to begin with, just a first baby step success would be a theory of conscious agents that it gives you clean predictions for what's happening inside a proton, the quarks and gluons inside, that predicts the distribution of momenta at all the Q square and the temporal and spatial resolutions that the physicists have probed so far. If I can start with a theory of consciousness outside space-time and actually give you the innards of the proton precisely, and there's many decades of data on this. So if I can first tell you, this is what this property of a dynamics of conscious agents corresponds to the mass, this corresponds to momentum, this corresponds to energy, here's spin, and here is distance. This is what corresponds to distance. I need to do that first. So I need to show, so instead of showing how consciousness emerges from physical particles, I have to show how a theory of consciousness gives rise to all the properties of physical properties, including their spatial distributions. Not because I think that's the most interesting thing to do with a theory of consciousness, it's not, but it's what I have to do to show that I'm onto something that's worthwhile. And that would just be the baby start. Once I've got the innards of the proton, I need to crawl my way up. So now how about the nucleus of an atom? And then the atom itself, and then molecules, and then macromolecules, and then climb all the way up to neuroscience. You might say, well, Hoffman, why don't you go straight to neuroscience? Because there we have the nice, clean neural correlates of and the answer is the same reason why I do addition before I try to do calculus. I mean, you got to start simple and work your way up. Yeah, the neural correlates are our ultimate target, but that's way too complicated. I need to go down. My baby step is going to be protons and the inner structure, because that's the simplest thing we know. That's the simplest we can do, and that's where we also have very, very hard data. So that's what. So I in some sense, of course, I'm interested in protons, but not more interested in protons than the brain. But the reason I'm going after protons is because just science. I mean, it's just that's where you have the best shot of making a connection, and also where there's so much data that if you don't have it, the data is going to say, no, you don't have it right. If your mass is off in the third decimal place, your mass is off in the third decimal place. You don't have that kind of accuracy in neuroscience yet. So that's where I'm going after. So that's my long answer to your short question. For the physicalist, they need to start with physical systems and explain specific conscious experiences, or frankly, I'm not terribly interested. There's nothing on the table. And for me, to get my colleagues interested, I have to explain exactly the momentum distribution of quarks and gluons inside the proton. I've got to get it right to several decimal places. And that doesn't mean I'm right, but at least it means if I'm wrong, it's still interesting. It's interesting to figure out where it's wrong. And of course, any theory is wrong in the sense that it's at best a limited version of something deeper.